The AI world is about to hit a whole new level, and 2026 is shaping up to be the year when artificial intelligence stops just assisting us and starts acting on its own. If 2025 was about AI writing, summarizing, and generating content, 2026 is about AI thinking, planning, remembering, and acting autonomously. From smart glasses to factory robots and AI PCs, every tool we've seen before is becoming a system that can take action, make decisions, and complete tasks independently. Today, we're breaking down 8 research-backed reasons why the AI of 2026 will be completely different from anything you've seen before. Reason number 1, Agentic AI becomes real. Imagine not just asking AI to write an email, but giving it a full objective. Find 20 leads, email them, track replies, and schedule meetings. That's what Agentic AI is bringing to the table. In 2026, AI won't just respond to your commands. It will act as a digital worker. Early tool use demos from companies like Google and OpenAI already show systems that can gather data, generate reports, send messages, and update documents autonomously. Startups are now offering AI workers for tasks like data entry and customer support, and they're closing real contracts with enterprises. This is proof that organizations are willing to trust AI with real work, as long as the results are accurate. Domain-specific AI matters even more here. Healthcare AI can analyze patient data and generate medical documentation. Legal AI can draft, review, and ensure compliance for contracts. Finance AI can monitor transactions and detect fraud patterns automatically. These systems aren't futuristic experiments. They're actively being tested in hospitals, law firms, and banks to reduce repetitive work. Once AI can act directly on software, data, and workflows, it becomes digital labor rather than just a writing assistant. This is the moment AI moves from helping us to actually doing the work itself. Reason 2, privacy-centric and sovereign AI. Not every organization can or wants to send sensitive data to a big cloud model. That's why 2026 is seeing a massive shift toward on-device AI and sovereign AI systems. Apple has introduced private cloud compute for iPhones and Macs, ensuring sensitive processing happens on Apple-controlled servers. Google released Gemini Nano for Pixel devices, which can perform tasks like smart replies, summarization, and transcription locally. Microsoft is rolling out AI PCs with built-in neural chips, and enterprises are deploying private models inside their own data centers. The benefits are clear. Running AI locally improves speed, reduces privacy risks, and keeps sensitive information under control. Industries like healthcare, finance, and government are leading this movement. If 2025 was about what AI could do, 2026 is about where AI is allowed to operate. It's not just capability, it's control, privacy, and compliance. Reason 3, AI moves into the physical world. AI is no longer confined to screens, phones, or cloud servers. Robots powered by language and vision models are learning through observation rather than rigid programming. Figure AI demonstrated humanoid robots trained with data from OpenAI models. Tesla's Optimus robots can sort objects, fold laundry, and perform other physical tasks based on visual understanding. Agility Robotics is running pilots in warehouses with bipedal robots designed to work safely around humans. Even hospitals are using AI-guided robots to deliver supplies, reducing staff strain, while cities are testing AI-driven traffic systems that optimize signal timing based on real-time congestion. NVIDIA is helping robots learn by watching human demonstrations, practicing in simulation, and then acting safely in the real world. The takeaway: AI is leaving laptops and phones and moving into machines that interact with the physical world. Autonomous systems that can act, adjust, and adapt in real time. Reason 4. Synthetic data fixes the data problem. AI needs data to learn, but real-world data can be limited, private, or biased. That's where synthetic data comes in. Artificially generated but statistically accurate, synthetic data allows AI to train without exposing real people's information. Google and NVIDIA use synthetic data sets to train self-driving cars and robots in virtual cities that mimic real-world complexity. Healthcare researchers generate simulated medical records to test diagnostic models safely. Cybersecurity teams simulate attacks to train systems without risking sensitive infrastructure. Banks experiment with synthetic financial data to improve fraud detection without exposing customer data. By 2026, synthetic data will be central to AI development. It allows faster training, safer experimentation, and more inclusive models. AI systems can be optimized in virtual environments before ever touching real-world data. A huge leap in both speed and safety. Reason 5. AI becomes explainable and trustworthy. One of the biggest barriers to AI adoption in high-stakes industries is the black box problem. You get an answer, but not the reasoning behind it. Medicine, law, banking, and government require more than blind recommendations. They need explanations. In 2026, AI models are being designed with explainability features, showing which data influence a decision and providing clear reasoning or alternatives. Regulators in Europe, the US, and Asia are demanding transparent AI systems with audit trails. The EU AI Act now requires labeling of AI-generated media, risk assessments, and compliance for high-risk systems. Google VO and OpenAI Sora are implementing watermarking for AI content. Banks are testing models that explain credit decisions, while hospitals trial diagnostic tools that show supporting evidence. When AI explains itself, it becomes trustworthy, which is essential for real-world deployment. Trust is the key to moving AI from experimental to everyday use. Reason 6. New AI hardware changes the game. AI used to rely almost entirely on massive cloud GPUs, but that's changing. Neuromorphic chips, which mimic biological brain function, are improving efficiency and reducing power consumption. Optical computing uses light instead of electricity to perform calculations faster. Governments and research labs are investing in AI supercomputers capable of simulating proteins, weather patterns, and scientific models with unprecedented accuracy. On the consumer side, laptops and phones with neural processing units can run AI models locally. That means less dependence on cloud servers, faster processing, and lower costs. Real-time reasoning, robotics, and AI-powered tools are becoming practical because the hardware is finally catching up. 2026 is not just about software. It's about the synergy of smarter AI and better, more efficient hardware. Reason 7. Generative AI goes beyond content. Generative AI isn't just making images, videos, or music anymore. It's being applied in science, medicine, interactive design, and gaming. Researchers use AI to design new proteins and explore drug candidates, reducing experimental time. Video models like Sora and VO turn text into realistic scenes for filmmakers and advertisers. Game studios generate environments, characters, and dialogue from simple descriptions. AI tutors adapt lessons in real time to student responses. Even wearable AI is becoming practical. Smart glasses can translate languages, answer questions about objects in front of you, or summarize text on a screen. AI-enabled laptops and tablets can create content offline without sending data to the cloud. Generative AI is no longer just a demo or experiment. It's becoming a feature embedded in everyday tools. enhancing productivity and creativity across industries. Reason 8. Energy-efficient AI becomes a priority. Training and running large AI models consumes enormous energy, and demand is only rising as models grow. The U.S. Department of Energy warns that data centers could consume a noticeable share of national electricity if growth continues unchecked. Companies are investing in energy-efficient cooling, chips that perform more with less power, and even exploring new power sources like small modular nuclear reactors. Rolls-Royce, for example, is developing reactors specifically to meet high-demand computing needs. Cheaper, faster, and more efficient AI is not just good for the planet, it also democratizes AI. Small businesses, content creators, schools, and startups can access AI tools without massive budgets. Automating tasks like scheduling, data cleanup, product design, and customer service becomes feasible for anyone, which drives adoption across sectors previously limited by cost. So what does all this mean for the world in 2026? The shift from 2025 to 2026 isn't hype. It's practical transformation. Jobs will change, of course, but new roles are already emerging. Companies are hiring people to oversee AI systems, review outputs, and design workflows. Robots and AI agents are filling labor gaps in logistics, manufacturing, and customer support. Schools and hospitals experiment with personalized AI assistants. Smart homes, factories, and cities are using AI to improve efficiency and automation. The pattern is clear. Humans set goals, and AI handles repetitive work. 2025 showed us what AI could do. 2026 is showing us that AI can do the work itself. It's autonomous, explainable, energy efficient, physically capable, and domain-specific. From acting like digital labor to operating securely on device, from generating synthetic data to explaining complex reasoning, AI is transitioning from being a tool to being a teammate. And the best part? This transformation is backed by research, real-world experiments, and commercial adoption. It's not theory, it's happening now. Healthcare providers, financial institutions, law firms, manufacturers, and tech companies are all piloting AI that acts, learns, and adapts on its own. The potential impact on productivity, safety, and innovation is enormous. So, what do you think? 2026 isn't just the next year for AI. It's the year AI steps up, moves out of screens, and starts working for us in ways we only imagined yesterday.